Welcome. Today's lesson is on limit laws. Limit laws are actually basically common sense. There's a little bit of technical detail to them, so you have to pay attention to that. But most of them, if the limits exist, things work the way they should. So, what do they say? They say if you've got two functions, f of x and g of x, and as x approaches one value a, whatever a is, 3, 75, 0, infinity even, if x approaches a, the limit of f of x is some value L. If the limit as x approaches a of g of x is some other value m, could be the same number, could be different. As long as these two exist, then the limit as x approaches a of f plus or minus or times or divide g of x is L plus or minus or times or divide m. Basically, any algebra in between, you can split apart the limits. If those two limits exist, we can just do the algebra. Now there's one condition, of course. If you divide, you can't divide by 0. Dividing by 0 is just bad, so don't ever do that. So, what does this say? It says if the limits exist, you can do any algebra on them you want except divide by 0. There's one other condition in the book. It says, for specific ones, x to the p over q, as x goes to a, is just a over p over q, a to the p over q. It's not really very complicated here. Basically, if you raise to a power, that's another rule. You can have L to the p over q, but it gets a little more complicated if you have negative numbers. Now, it's important to realize, if one or both of those limits don't exist, the limit laws don't apply. So if this does not exist, you can't just say does not exist plus 3, because that doesn't make any sense. If it does not exist, this might actually exist. By the way, DNE stands for does not exist. So that's all of the technicalities. Let's do an example, or two, or three. Suppose the limit as t goes to 2 of f of t is 7. The limit as t goes to 2 of g of t is minus 3. So what do we have? The limit as t goes to 2 of f of t minus g of t. All over g of t squared? Well, what is that? This limit exists, this limit exists. So we can do any algebra we want on it, as long as we're not divided by 0. Well, what's this top if we just do the algebra? This is going to be 7 minus 3. Don't forget minus makes plus. And the bottom, minus 3 squared. And I'll just plug that into your calculator as negative in the 3 squared. But what do we get? We get 10 ninths. And it works perfectly. This is as simple as it gets. For something complicated, limits are complicated. Algebra is complicated. Plugging it in is simple. Now what about this one? This one's more complicated in some ways, but it's really not. We have t squared times f of t. But what do we do with this? Because we don't know anything about the limit of that, do we? Well, t squared is of this form. T to the 2 over 1 is going to be the value to 2 over 1. We do know that. This is 2, this 2 here, to the 2, times the limit of f of t. It doesn't matter. Extra t's, they're fine, because they're a function by themselves. Now, that's if the limits exist. What if they don't? Let's take a quick example. There are so many ways this can work that I can't possibly list them all, but here's one. The limit as t goes to 0 of 1 over t divided by 1 over t squared. The top, if t goes to 0, try this out. That graph looks like this. It gets very unhappy at 0. It doesn't exist at 0. The function doesn't and the limit doesn't. What about 1 over t squared? It also gets unhappy. You might argue that this has a limit of infinity, but either way, it doesn't really exist. However, does not exist or does not exist might work, might not. You can never tell unless you look at the particulars. What are the particulars? T goes to 0. Well, what do I have? I've got 1 over t, that's the top. Dividing by a fraction is the same as multiplying by the reciprocal. And what do I get? T squared over t. T squared over t. Now I could just plug those in. Both of them have limits, but the bottom, of course, is 0. Can't have a 0 on the bottom. But I can divide. So I have t over 1 as t goes to 0. If t goes to 0, what is that? That's 0 over 1, which is 0. Sometimes it works. Until next time.